that you gave or were broadcast yesterday. I love the lectures, and I'm sure thousands of people around the world did as well. So thank you very much. Now I'd like to welcome the representatives of the national and international media. In a normal year, you would have been here at the Academy together with our Nobel laureates. And it's such a pity that we cannot welcome you this year. But we all know that this year is not a normal year, and we'll have to do with video links, and I'm sure it's going to work out fine technically. We feel, and I think the laureates feel, that at this time in history it's more important than ever to deliver positive messages about the progress of science and mankind to the world. Now let's go over to the questions. And I will give the word to each one of you when it's your turn. And please limit yourself to one or maximum two questions, and don't forget to switch on your microphone when I give you the word. So let's start without further ado. And the first question comes from David Keaton of Associated Press. Hello, David, please.
Hello, and thank you very much for this opportunity to ask a question. I think in this same idea, talking about the pandemic, a question for all the laureates, and to what extent has the global coronavirus pandemic maybe given a special extra meaning to the Nobel Science Prizes this year in particular?
Shall we start with our microbiologist, Dr. Charpentier?
Yes, for sure. I am a microbiologist, and as a matter of fact, the CRISPR-Cas9 topic that was awarded this year for the Nobel Prize in Chemistry is really based on research trying to understand how bacteria defend themselves against the infection by viruses. So we can be obviously infected by viruses. I think people have understood it by now. Bacteria as well, and they have developed a defense system. And this understanding of one of the defense systems has allowed to lead to this very powerful gene editing technology. So it makes really even more sense. And when you look at the speed at which different vaccines now have been developed against SARS-CoV-2 after even not a year. This pandemic for sure highlights tremendously the need of basic science, and specifically in the field of infectious diseases, not because of what we are experiencing today, where we need always to react fast, developing new vaccines. You have also the threat of antibiotic resistance, and because also we know to which extent working on bacteria and viruses has led to the development of multiple technologies that have been used in molecular biology, genetics, and biotechnology. So it really makes very much sense to highlight once again the need of fundamental science, even if it is to work on macroorganisms.
Thank you. Shall we ask Dr. Milgram about the socio-economic consequences of the pandemic? Would you like to say perhaps a couple of words about that?
Sorry, I guess I was muted there. Let me just say a couple of words about the socioeconomic part of the response to the virus. It was very important that these new ideas about spending the money in advance speculatively, which were suggested by last year's laureate actually by Michael Kramer, that be put into place so that we could respond rapidly. That there was and there's continuing work about distributing effectively the vaccines that are created. This, of course, is the fundamental science is. This isn't really so much about fundamental science as about making good use of economic knowledge so that we can get this vaccine created quickly and distributed effectively. But I think that too is very important, and that knowledge will help save lives.
Thank you. Dr. Guest, from your perspective as an astronomer and a physicist, What's your thoughts on this topic, on this question?
Well, I think as Emmanuel said, it really stresses the importance of basic science. You don't always know what the applications are going to be, but it's really important as a society that we invest in basic sciences in all areas. And I guess from my perspective, I would also say at this moment, it really emphasizes the importance that we engage the public with scientific process and scientific thinking, and encourage the next generation to think about what it means to engage in scientific thinking, critical thinking, and deep and authentic conversations.
Thank you. Great. So let's move to the next question and bring in Maria Gunther from Dagens Nyheter, a major Swedish broadsheet newspapers. Hello, Maria.
Hello. Yes, my question. I also have a question to all the laureates. I would like to know what you donated to the Nobel Prize Museum and why.
Dr. Gez, you haven't had a chance to deliver it personally, but
no, not yet. We've been thinking quite hard about this. I think I'm settling on the first recording of our data in 1995. It's in an exabyte format, and the reason I like this idea is that it forces us to recognize how long this experiment has been going on and the evolution in technology on so many fronts. So even the medium in which we store our data has had to evolve. So it really captures both the technological progress and some of the real challenges that we face today of how do you keep a data and code development alive and a collaboration alive for 25 years. These are actually non-trivial science infrastructure questions.
Shall we move on, Dr. Charpentier?
You're muted.
Sorry, I still did not deliver my gift, so maybe I can change my mind. But the issue with me is that I traveled a lot, and I tend to try to not be too materialistic. So I try to, let's say, not keep too many things. But as a matter of fact, I have always traveled with something from the Pasteur Institute, which I took. I was allowed to take it when I left. These are these very old racks in wood, whereby one can stand the tubes. And actually, I think it's nice because it's also, actually, I found the same kind of racks at Charité in Berlin, in the Robert Koch Museum. So obviously, this is what was used at the time. But as a matter of fact, the racks are still the same in nowadays. And for me, it's a good image because it's linked to the fact that, however the technologies are developing, we are still, us biologists, bound to these tubes that we have to place somewhere. And this will be, will be the case in years to come.
In the great tradition of Pasteur and Koch. Yeah, Dr. Milgram.
Yes, so what I have is and we'll donate, is a chart that shows how the uses of the radio spectrum in the United States has changed. That's signed by two of my favorite people from the Federal Communications Commission with whom I had worked closely. So it was a chart showing how the allocation of radio spectrum has changed as a result of our work, and assigned by the people at the Federal Communications Commission who were in charge of the implementation and made it all happen.
Great, shows the importance of the research. Now let's move on to Ny Teknik, New Technology, and Anja Obminska. Hello.
Hi.
What's your question?
Yeah, I'm not sure if everyone can answer this, but I'm curious if you can talk a little bit now. You've mentioned it somewhat, but a little bit more about what technologies or innovations made your findings possible. Is there something you want to pinpoint?
Maybe I could ask Dr. Gez to tell us about your new way of running the telescope in Hawaii, because that shows how new technology makes things possible also in this particular time.
Actually, there are two really important aspects. I mean, technology, new technology has been so important and really at the root of the work on my end. So we are studying the center of the galaxy. We have to look through, because we live in the galaxy, we have to look through a lot of dust. So the wavelengths that we use are at infrared wavelengths. That's where your TV remote control works. It's just long word of what your eye detects. So the development of infrared technology has really been essential. So our ability to detect that kind of light that opens up our ability to see the information that's being carried from the center of the galaxy to us. And then the second so that was really has moved a lot and opened up this research. But the second really key technology is our ability to correct for the blurring effects of the Earth's atmosphere. So we have really big telescopes. We use the largest telescope in the world in Hawaii. But to take advantage of the theory that a big telescope allows you to see very fine detail, requires that you overcome this distortion introduced in the Earth's atmosphere. And over the last 25 years that this work has been going on, the way in which we carry out those corrections has evolved radically. So we've started with very simple techniques. And we do this because we're always driven by the science. So use whatever technology is ready to be scientifically, in a sense, you could say harvest. And then halfway through, we really took advantage of a new technology called adaptive optics, where there's been a co-evolution of that development in the military, because of course the military also cares about looking up and down. But maybe the other thing to point out is that this is where astronomy and astrophysics has a really strong connection with other fields, because the ability to see through distorting media has a role both in vision science. So people who want to study the retina have to image through the eyeball. So that's a distorting media. So we've actually worked alongside vision scientists. Communication, so through fiber optics, which also can distort your signal. And then these techniques have been applied to areas like mammography. So it's another area which you might think the development of astrophysics is, has no application, but it actually shows up in really surprising places where you might not have intended in the first place.
Thank you. Great. Now we'll move on to Ivan Loganov from Agra Press.
I think you forgot me.
Oh, sorry. Well, I thought there are so many who want to ask questions, so that's why I moved on. But please, feel free to comment.
Yeah, let me just say, so most recently, for example, it's advances in computer science that have been so important to us. In a recent auction we ran, the problem of even checking what kinds of things were feasible is what's called an NP-complete problem, which means that there aren't any algorithms that are guaranteed to run fast to even solve those problems. And we had to build an economic system on top of that could operate effectively. So that's where the innovations in the economic design were. But on the computer science side, one member of my team, Kevin Leighton-Brown, found a way that was a 3 order of magnitude improvement in how rapidly we could check the feasibility of different allocations of television stations onto the spectrum, so that we could run an effective auction in real time most of the time. That is, it became much more possible to design something that worked in a complex environment because of advances in computer science, which, by the way, were going on before us and which our team contributed to help make this design work.
Thank you. Now let's move on to Ivan Loganov, who I think has a question for Dr. Charpentier. Let's hear.
Thank you very much. Mr. Charpentier, you often mention agriculture as a field second to medicine where CRISPR-Cas9 can be useful. My question is, what have been so far and what will be, according to you, the most innovative or meaningful application of CRISPR-Cas9 in the agricultural sector? Thank you very much.
Yeah, so first of all, it's a technology for sure that is very much welcomed by plant biologists that have the goal to understand the functions of genes, discover new mechanisms, etc., and understand also the challenge of plants and crops to face changes in the environment. So this is important to in a way predict also the kind of mutations that will arise or that will allow actually plants to resist different conditions that will be found under global changes of temperatures. So this is important to anticipate because it allows to then understand better how plants react, how plants resist, and to be able to use the CRISPR-Cas9 technology to very precisely generate those plants that will be able to cope with the challenge of global warming. So these are important issues, and also the fact that one should not understand that should not underestimate that the former technologies that were used, such as breeding, or the former genetic technologies were affecting, at least for the breeding, more than one gene, or the chemicals have for sure more detrimental effect than just using a technology where we know precisely what we are doing. So it's more about what we let's say taking a decision of which plant we want to generate rather than using a technology that may have other, let's say, may target other genes or other mechanisms of the plant.
Thank you. Next question comes from Lena Nordlund, who is at Vetenskapsradion, the science radio here in Sweden. And she's just switching on her microphone.
Wait, yeah, there. Hello, my question is for Dr. Guest. And this special year has been very special for everybody and for scientists. I spoke to a theoretical physicist in the Nobel Committee. He said that this quiet time had given him more time to think and could even have been good in some ways. But he said that also it must have been worse for experimental physicists. And also Penrose said something like this. So what I wonder, how has it been? Have there been advantages for you or only disadvantages?
Well, there's certainly both in my case, and I think most people's case. My laboratory is the telescopes primarily. So initially the telescopes were closed. And in fact, there's a season or a part of the year where we collect our data. So I often say our work is quite seasonal. So we start in the spring and we end in the fall in terms of our ability to collect data on the center of the galaxy. So the fact that the pandemic closed things down in the US in March was just at the moment that our season was starting. So we certainly lost half our season as Keck Observatory. And in fact, this is observatories around the world were closed at this point. But because of technology, I mean, Paul Milgram already mentioned computer science. Our ability to remotely access and operate things has changed dramatically in recent times. So it became possible to starting in June, to open up the observatory and to start to collect data. So it is amazing to me that even in the midst of a pandemic, that we could collect data from the mountaintop of Hawaii. So it was one person up at the summit, and the rest of us at home operating remotely. So thanks to technology, we weren't completely shut down. And then, the rest of the year and the rest of the days, even during this part of the year, it's all about data analysis. So we have the data is on some computer, which you can access remotely. So this is where the very positive side came in. Our collaboration has expanded dramatically from a team that only resides at UCLA to one that is quite distributed. And because we didn't intend to be a distributed team, there's all sorts of interesting collaboration issues about how you access the data, how you code in a common environment. And now our team at UCLA really has been put in the same situation as everybody from the outside. So we're all now outside looking in. So it's given us this wonderful opportunity to understand some of the collaboration hiccups and to have the time to work on improving our ability to collaborate with a broader network of people.
It's impressive, sitting in your living room and running a telescope in Hawaii.
Yes, that was it's a rather bizarre thing to be up all night on your computer operating something many miles away.
And did some of these solutions sort of speed up or happen during this year because it was this year?
Absolutely. These things would not have happened. We wouldn't have had the time or prioritize this kind of work had it not been the pandemic. So there are some things that are much harder for us to do. It forces us to think about and actually to see as an obstacle that has to be overcome during the pandemic. So yes, there's definitely been some opportunities to work on new and different things.
Great, thank you. So we'll move on now to the economic section of Dagens Nyheter. Carl-Johan von Seth, please.
Yes, hello. I've got a question for Professor Milgrom. I understand that you have some private experiences from auctions. So I wonder, what was the most expensive item you ever bought, and whether you became a victim of the winner's curse?
Dr. Milgrom.
There we go. I was muted again. Well, of course, I have a couple of items in mind for myself. One, the winner's curse, and one almost the opposite. The house that I live in, I've told this story many times. When my wife and I were coming back to Stanford, there was only one house she was interested in, and I was tired of moving. Didn't want to rent for a year, so I ended up paying quite a lot of money for the house we moved in. But we've been happy. This is what we talk about the winner's curse, but we've been happy in this house for 20 years. So I guess paying too much and being in a house where you can live well and be happy isn't so bad. The other story that I had, though, about an auction is I have a piece of sports memorabilia, a really famous piece of sports memorabilia. There's the most famous sports play in the San Francisco Bay Area is something called The Catch, and which was a throw from Joe Montana to Dwight Clark that won the championship in 1982. And I have the ball that was thrown on that play. And I acquired that at an auction that was poorly designed. And I saw this and thought, this doesn't make any sense. There's an easy way to game this auction. And so I did, and I won the item. And it's sitting on a side shelf over here where the most famous sports memorabilia in the Bay Area. So anyway, yes, you can use these theories in practice sometimes.
Wonderful, thank you. Now we have a question from Carmen Rodriguez Sanchez of the EFE, the Spanish news agency. Please.
Hello. I have a question for Professor Champentier. It's about basic science. So at the base of the development of CRISPR technique, there have been many scientists. Among them, there is the Spanish Francisco Mojica. So I want to know what was the importance of Mojica's research and in general the importance of basic research for the development of science.
Yes, so with regard to CRISPR, it started in 1993 with a Japanese group identifying some elements of CRISPR. And then biologists, including Francis Mojica, were very, very important because if they could actually find again those elements and understand that they were present in various bacterial species. And this is really critical because CRISPR is all about evolution. So this was a critical work at start to really understand that these CRISPR systems were existing in multiple species. So this is, this is really the start of CRISPR biology research. When I came actually into play, there were already 3 types of CRISPR-Cas systems known in multiple bacterial and also archaeal species, with one mechanism of one of those types that was understood. And then I was just lucky to work on a bacterial pathogen for humans that had one specific CRISPR system that was already studied by the groups of Moineau and Horvath and Barangu. But the mechanism by which this specific system was working was not understood fully. And this is where I jumped in, and where after my collaborator joined me. So yeah, but it's important because what you mentioned is to highlight that, it's always different pieces of the puzzle put together. You always, profit of the work of earlier pioneers, of your colleagues, and but the prices, they highlight some scientists who may have done some important work at some point, but the fields of research that we are all representing as awardees involves multiple scientists who are doing great science in the fundamental aspect of the science. Mm-hmm.
Thank you. We have just a few minutes left and several questions, so if we can keep the questions as fairly short. Now a question from Reuters news agency. Simon Johnson, please. We can't hear you.
Good afternoon. First of all, congratulations, of course, to all 3 of you on the prizes. It's a lifetime achievement. I guess you won't get another one. Who knows?
This was a lifetime achievement. Remember, these prizes are not lifetime achievements. They are for specific contributions.
Apologies. This was intentionally, at the start was going to be a question for Professor Milgram, but I guess it could go to everybody, which is, what research in your area do you think should be given the Nobel Prize if you were to give it yourself?
Dr. Milgram.
Ooh, you want us to name people?
No, don't. Just mention fields.
I don't want to.
Don't give the committee too hard a job.
Yeah, so there is other work that's being done, especially using big data and methods in computer science. And also one of the things that computer scientists didn't do when they developed their big data technique is they identified only correlations. We're interested in causation when we do policy analysis. We want to know when we change things, what will happen, what will be the outcome of our policies. And there have been economists who have been working on adapting big data technique to do causal inference from data. And I think that stuff is extremely important. And something, much of the work on big data about how are we going to deal with income inequality? How are we going, what policies are going to be effective? Inferring that from data that appears to be only correlational. There's brilliant work that's been done on that. And I think some of that could be the next, could soon be Nobel worthy.
Thank you. I think we'll have to move on. Do we have more questions? Yes. Now we have one from China Radio, Chen Axelsson Chefei. Are you there? Yes. Hello.
Yes, I must unmute. Yes. Thank you for giving me the chance, and congratulations. My question is to Professor Emmanuel. So, when you find these so-called the genes scissors, it get such a big reaction in the world, and it seems a lot of things can be possible. So do you think that, for example, in terms of, we have a lot of inherited disease and or some kind of chronological, can we, with your sort of bio scissors, modify the genes and find a treatment? For example, in this inherited disease case, or also in the cancer patients? What's your comment about this?
Yes, so actually the technology has been developed and is now used to treat patients with genetic disorders. So you have patients with blood genetic disorders, beta thalassemia and sickle cell anemia, that have undergone some treatments with CRISPR. And so this was done at least by the company CRISPR Therapeutics that I have co-founded, and together with Rutger Novak. And there are already some patients, about 10 patients with sickle cell diseases and beta thalassemia that are living without the need of blood transfusion, thanks to the technology, by combining the gene editing technology CRISPR with cell therapy. So it's a huge, huge progress of the technology, also to treat patients with certain types of cancers. And here again, there are some clinical trials going on with regard to patients having blood cancer, such as leukemia, that are treated with the technology by combining the technology with immunotherapy. So this is the idea of engineering, thanks to the CRISPR-Cas9 technology, immune cells, T cells that can recognize the sick cells, the canceric cells, and destroy them. So you already see some results.
Thank you.
In medicine.
Thanks. The last question will come from the Swedish news agency TT, Niklas Svan.
Thank you. I think Andrea Guess has partly answered this question, but I would like to maybe Emmanuel Charpentier and Paul Milgrom can answer it too. How are you experiencing that the pandemic practically has affected your field of science, and can you give an example of that?
Emmanuel, do you want to begin?
Oh, no, Paul, you please start.
Okay, well, in my case, most of the work that we do, we've been able to continue on Zoom, but I have noticed that it's very difficult caring for my graduate students. I have a large group of graduate students I work with, and isolation and depression are definitely a problem and a distraction now. And, you know, so I've increased the amount of communication I do with some of my students. I'm trying very hard to provide support, because it's very difficult being a graduate student. When you're doing research, there's a lot of failures, and when you're alone and you're failing, it can be a very difficult time. So I think that's the single biggest challenge that I've been trying to deal with, is supporting the graduate students.
Thank you. Dr. Charpentier?
Yeah, so this is the same as Paul mentioned. I think this is difficult for the young scientists. I mean, you know, research works with young scientists. So in my case, I had to close my institute for 5 weeks. This was not really a problem because, you know, I think sometimes it's good to reflect on your project of research, as, you know, if you have more time to read the literature or read papers you did not have time to read. So I think for my students and postdocs, the closure of 5 weeks was not such a problem. What was a problem is to go back to work and not be able to interact the proper way, not being able to have lab meetings where people, you know, look at one another, discuss with one another. The social activities are very important in science to foster the team spirit, to allow the people also to know one another, to be able to work together, ask questions, go ahead, have new ideas. And all this aspect is a little bit gone. So it's a bit frustrating, I have to say. And for them, it's so important also the possibility to go to conferences, to meet other people at the early stage of a career. This is more important than that later stage of a career. So this is, I believe this is quite dramatic for the young people, actually.
Thank you. And now I think it's time to conclude this press conference. Could I ask the Nobel laureates to please stay online for individual interviews. And to all our viewers, to the press, and of course to the laureates, I say goodbye from Stockholm.